All right, here we go. You probably will want your calculators available, so good idea to get those out. All right, today is September 4th. We are talking about piecewise functions today. Keyword being, it's a function. If it's a function, what do we know about it? Okay, good. So I heard two things. It passes the vertical line test, and each input has only exactly one output. Now, so you know what it means to be a function. You guys just told me two excellent things about a function. And so what's interesting about piecewise functions is that when students get to a piecewise function, all of a sudden they forget what it means to be a function. First and foremost, it is a function. And so when we go to evaluate a piecewise function, if you plug in one number, how many numbers should you get out? One. So our very first thing we're doing is evaluating a piecewise function. You're going to plug in one number and you're going to get one number out. Okay? Don't give me like 7 answers. Oh, quiz. Oh, quiz. Yeah, look at that. You do a quiz. Yeah. That's
sure
your.
Cancel it?
That's your next test.
Maybe the one that will rate it out.
Just so you know. Yeah. It's there for a reason. All right. Here we go. Here we go. Example 1. Evaluate the function g of x equals this. This is an example of a piecewise function. Piecewise functions are not a part of the Algebra 2 curriculum anymore. Many moons ago they were. So it's hit or miss as to whether or not your Algebra 2 teacher taught it. So you're going to learn piecewise functions in this class now, even if you haven't learned it before. A piecewise function is made up of pieces of functions. That's why it's called piecewise function. And so we have this kind of interesting function here. And what I want to say is that this is how most books write a piecewise function. I want you to add in a word. G of x equals 2x minus 4 if x is less than 2. And g of x equals negative 1/4 x plus 8 if x is greater than or equal to 2. By adding one word, I have created a conditional statement. And I love conditional statements. My kids have been trained on conditional statements. Mom, can I have some dessert? Yes. If you eat your vegetables, then you can have dessert. It's an if-then statement, and we all understand what that means, right? What does that mean?
Yes.
If you eat your vegetables, then you can have the dessert, right? So we want to make sure that when we are evaluating a piecewise function, that we make sure the condition works first. Have you satisfied the if portion? Okay, that is the condition. If our x value is less than 2, then we're going to evaluate 2x minus 4. If our x value is greater than or equal to 2, then we get to use the bottom equation. Got it? It's an if-then statement. So we want to find g of 0. What does g of 0 mean? Oh, it means that x is equal to 0. If x is 0, which equation do we use? The top one. Why? because 0 is less than 2. That's a true statement. So we've satisfied this condition. And so we get to evaluate using 2x minus 4. So 2, plug in the 0, minus 4, and what do you get? Negative 4. Okay, now we want to find g of 1. What does g of 1 mean? X is equal to 1. Do we use the top or the bottom equation? Top. Thank you. I don't know if you need to know now. It seems ridiculous. So we use the top equation again because 1 is less than 2. That is a true statement. Is 1 greater than 2?
No.
No, that's a false statement. I can't plug it in there. It only works in the top. So now we can use the equation 2, plug in a 1, minus 4. And we get negative 2. Okay? What does find g of 2 mean? Plug in a 2. It means x is 2. Do we use the top or the bottom? Bottom, why? Yeah, because 2 is greater than or equal to 2. So this condition is satisfied, so we can use our second equation. So negative 1/4 x plus 8. Oh, and what am I plugging in place of x?
2.
Plugging in a 2. That would be what? Negative 1/2 plus 8? 7, yeah, can I 7.5, okay? Yeah. All right, here we have x is equal to 3. Top or bottom? Bottom, because 3 is greater than 2, so the bottom works. The top is false. So negative 1/4, plug in a 3, plus 8. That's negative 3/4 plus 8, which would be 7.25, which would be great. Okay, super. Now you know how to evaluate. You'll notice we had 2 equations. Did I have 2 outputs? No, 1 input, 1 output. That's it. Okay, now we're going to graph. So graphing is a little bit weird, and every time I teach this, I teach it a little bit differently. But I like this method. It works pretty good. What will happen is when we're graphing piecewise function, and this is what your homework is mostly tonight, is graph.
Tonight? Does that mean we're doing house?
Hopefully you'll get it done in class. Okay, so it's 8, well, it's 10 problems, but I want you to do 8. Okay. Okay, so what happens is we have 2 functions. So we're going to graph one function, and then it has this switch, and it switches to the next thing. So right here where we have the condition, this is where things are changing. When x is equal to 2. We're going to graph one line when x is less than 2, and we're going to graph the other line when x is greater than or equal to 2. So there's a change happening when x is equal to 2. I like to call this the boundary line. And the boundary line is where things are going to switch up. We're going to change from one thing to another. So I'm going to start by graphing my boundary line, x equals 2. It's nice to have a little boundary line. It's just for reference for graphing. It's not really there. So there's my little boundary line. What this boundary line tells me is that to the left, these are all the x values that are less than 2. So here's x is 1, x is 0, negative 1, negative 2, negative 3. These are all x values less than 2. And over here, greater than 2. So what I'm going to do is I'm going to use different colors. And I'm going to start by graphing this first equation, y equals 2x minus 4. Now this is a line. I do expect that you all know how to graph a line, especially a line in slope-intercept form. What is the y-intercept? Negative 4. It is a y-intercept. Do you graph on the boundary line? No, you graph on the y-axis. 1, 2, 3, negative 4. And then it has a slope. What's the slope? 2/1, which tells you to go up to right 1. So I'm going to do that. Up to right 1. Up to right 1. I'm going to keep going up to right 1. This line extends in both directions forever, okay? So I could graph and fill in that whole line, but I don't want all of the line because it's conditional. I only want to see this green line for x values less than 2. So here's where x is equal to 2. Do I want the left side of this line or do I want the right side of the line? Left, because that's where x values are smaller than 2. So I want the left side of that boundary line. At the boundary line, should I use an open or a closed circle? Open circle. So I'm going to make a nice big open circle there so it's really clear. Do I need the right side of that boundary line? No, so I just erase. Okay? Then I need to graph my second equation. Again, the equation is y equals negative 1/4 x plus 8. The line, it's in slope-intercept form. What's the y-intercept? 8. 1, 2, 3, 4, 5, 6, 7, 8, right there. And what's the slope? Down 1, right 4. So we're going to go down 1, right 1, 2, 3, 4. And go down 1, right 1, 2, 3, 4. Okay, sort of bad graph, whatever. This line normally would extend in both directions forever, but we don't want the entire line. We want the condition. The condition says the x, we only want this line for x values greater than or equal to 2. So, do we want the left side of the boundary line or the right side of the boundary line?
Right.
Right side. So what I'm going to do is let's say I draw my line. I know I only want the right side. At my boundary line, should I have an open or a closed dot? Solid dot because it's equal to. So I'm going to put a nice big giant solid dot there so it's really clear to me. That's a solid dot. And I want the right half of the line. So what do I get to get rid of? The left of the boundary line gets erased. Okay. So my boundary line is where we change from one function to a different function. Is it a function?
Yeah. Yeah.
Yes.
Yes. Yeah.
Okay. Yeah. So it's always a little bit confusing, but yeah, this is a function. The green dot is an open dot. Is it included? No, it's not really there. This one is solid. This is the point, and in fact, we found that point 7.5. We found g of 3. Here's 3. This is the point 3, 7.25. We found these points as well at -1. We're here at -2, -1, -2. And this point was 0, -4. So you can actually use evaluating to help you graph. But I like just thinking about the graph with the boundary line. I think it really helps. Okay? It is a function, first and foremost. It does pass the vertical line test. So if you go and you draw a piecewise function, it better pass the vertical line test. Okay? All right, let's try. You've got some real interesting problems today on your worksheet. Let's do one more of these. Graph the function, a little more complicated. You will need to use your calculators today to help you graph these piecewise functions. That's why you have them. All right, we have f of x equals. You'll notice I put the ifs in for this function. It won't normally be there. Math people are notoriously lazy. So we have a function 2 minus 1/2 x. If x is less than -2, f of x equals -2 if x is between -2 and 2. And we have -x² + 4 if x is greater than 2. question to you will be, where are the boundary lines? Yeah, we've got information when x is equal to -2, some sort of change is happening, and then where else? +2. Yeah, so at x equals 2 and x equals -2, we've got changes happening. So in this case, there's 2 boundary lines. And when we draw those boundary lines in, you can see that we get our graph sort of split apart into 3 sections. And you'll notice there are 3 functions. So each section, the left section, the middle section, and the right section, are going to be a different function. So I'm going to start with my top equation here. That's y equals 2 minus 1/2 x. Again, it's in slope-intercept form. What's the y-intercept? 2. What's the slope? -1/2. Down 1, right 2. So I'm going to go down 1, right 2, down 1, right 2. I'm going to do that in reverse as well. Up and back 2. Up and back 2. So I want to extend my line in both directions. And then ask myself, well, what section of my graph is my green line active for? Which x values? Less than -2. Where is less than -2? Yeah, x values less than -2 is over here to the left of the boundary line. So I want that part of my line. At -2, open or close dot? Big open dot here. So I'm going to make that a nice big open dot. What should I do with my other dots? Yeah, get rid of them. We don't need them. So when you do this, I recommend using pencil or erasable pen, which is what I love that. Okay. All right. Second portion is the equation y equals -2. What kind of line is that? Horizontal line. Very good. It tells me to go to -2 on the y-axis and draw a horizontal line, which normally would be just like this. Do I want the whole thing? No. What do I want? The middle. For x values greater than -2 and less than +2. At -2, open or close dot? Solid dot, because we're equal to -2. So I'm going to put a nice big solid dot on my boundary line. At +2, open or close dot? Open circle. So I'll put a nice big open circle there. And so I just want between -2 and 2. So what should I do outside of there? Erase. We don't need that part. Okay. And then the last portion, I'm going to say, what shape is it? Upside down parabola. Very good. Maybe you know that and maybe you don't. But I'm going to say, when in doubt, graph it out. So what we're going to do is we're going to use our calculators whenever we need to. And I'm going to type in my function. I'm going to graph it. And I knew that it had a y-intercept of 0, 4. And I knew it was an upside down parabola. But I want some more values. So guess what? You have a table. So we're going to go to the table and find some ordered pairs. So let's see. -3, -1, 2, 3, 4, 5. -2, 0. -1, 3, 0, 4, 1. What kind of function is this? Symmetric to the y-axis. Very good. So I went to the table and I used my table to find some ordered pairs. So there's my downward facing parabola. Which part of my graph do I want for this? The right side. X values greater than or equal to 2 is to the right. So I just went to the right of my boundary line at 2, solid or open dot? Solid dot. So I'm going to pick a nice big solid dot. And what should I do with those other ordered pairs? Yeah, get rid of them. We don't need them. Okay. So we are literally piecing graphs together today. All right. You can use your calculator to help you if you don't know what the shape is. I don't expect you to at this point. That's why we have calculators. Do you have questions for me? Oh, yes. Good question. All right.